if you have ever been confused about is and is equal to in Python, especially when they look the same, but sometimes they give the same results and sometimes they don't, then this video is for you. Today, we will clearly understand how is different from is equal to and why Python need both. And we will also understand how Python checks whether a value belongs to a list, string, or a dictionary. Hello learners, welcome to your learning hub, The Learning Loop. I am Swati Sharma and this is the 21st video of my beginner friendly Python course series. If you are joining me for the first time, thank you for dropping by. And if you haven't checked out my previous videos yet, I will highly recommend you to go back and check those out. Before we move forward, if you haven't subscribed my channel yet, please go ahead and press the subscribe button and hit the bell icon so that you do not miss out on future videos. In this video, we will cover the next two operators, that is the identity operators, which include is and is not, and membership operators, in and not in. So without a further ado, let's dive in. Let's start with identity operators. Identity operators don't check what the value is, they check where the value lives. Before we jump in, there is a small idea that I need you to remember. Everything in Python is an object and every object lives somewhere in a memory. So when you are creating a variable, you're not storing a value, you are creating a reference to a memory location where the object lives. Let's understand this with an example. Let's say I store a variable or I declare a variable x and I store a value 5 in it. Okay, now this 5 is an object. This 5 is an object which is stored in a memory. So let's say there is a memory. Now this is a memory. And now I am storing this value or this object in a memory. Let's say this is where I stored the value. Now this would be given some location here, or the address or location or some hex value that we can check using the ID. Okay. So whenever I'm declaring this particular variable x, I am referencing to this particular location. I am referencing to this location, not directly storing the value in it. So when I say x is equal to 5, I stored somewhere in the memory location. Let's say, let's call it like ABC. Let's say that's an address. So every time I'm declaring x or calling x, I'm saying, oh, okay, please go to whatever is at the location ABC. Check what is at location ABC and you will get, oh, it's a 5. So you will fetch 5 from there. Okay. Same ways, if you declare y is equal to 5, it is going to point to the same location, that is ABC. Now it does that for small integers to save the memory so that it doesn't have to create multiple memory locations for different integers. Okay, so I just want you to understand this idea, because when we are understanding why is not same as is equal to, this will make a lot more sense. Python gives us two identity operators, is and is not. Let's start with a very simple example. We are doing today's demo in Google Colab, and I will be also pasting the link in the description box so that if you want to go ahead and check this code out in future, you can go ahead and check that out. Let's take an example where I say a is equal to 10 and also declare b is equal to 10. And now if I check if A is B, you should get that as true. Let's see that. And we can see the answer as a true. And with this, the confusion starts because A is also 10 and B is also 10. The beginners think that, oh, okay, it must mean a second equal to, or it means equal to, which is not very true. Let's just quickly check the ID. We will use the ID function to check the memory location. Now let's check the memory location for each of these objects or the variables. Print ID A and print ID B, and I'm gonna run it, and you can see the location is exactly the same, right? And that is why you are getting the answer as true. Now Python is smart. What it does is, for small integer, it reuses the same memory location. So when you stored A is equal to 10, it created a memory location and stored that value. And when you also again declared the same value, instead of creating a new memory location, it started referencing to the same one to save the memory and increase the performance. Let's change the data type and let's see what happens when we use is with list. Okay, let's say I declare a list 1 and I'll say is equal to 1, 2, 3. And let's say I also then declare a second list, which is also the same. And now we will see if list 1 is list 2 gives us true or not. You can see we got the answer as false, which clears the confusion that it doesn't mean that if the values are same, because we can see list 1 and list 2 are exactly the same. And if I use is equal to here, you will get the answer as true. Let's do that as well. You can see the is equal to is giving us the answer as true. Let's do more. Just do this to avoid the confusion, and you see it says is equal to true. Now to further check this, let's check the memory location for each list, and that would clarify your confusion. And you can see the memory location is different for both the lists. Now, because both the lists are same, you might be wondering like why Python not stored or referenced to the same value. It's because lists are mutable, and if you change any one of the lists, that might create a lot of trouble or confusion in future, or mess up with the list 2 as well if we change the list 1, because they are referencing the same location. To avoid everything, Python use 2 different memory locations to store these lists, even if the values are the same. Is not is exactly opposite of is, which means it will check if the memory locations are not same, which means the list 1 and list 2, if I use the is not, would give me the result true, because we know that the memory location of list 1 and list 2 are different. So if I do print list 1 is not list 2, and I'll hit, and you can see it's said true, because obviously they are not same, and that's why we are getting that as a true. Now let's move to membership operators. Membership operators check whether a value belongs in a list, tuple, sets, frozen sets, strings, or dictionaries. We have 2 membership operators, in and not in. Let's quickly understand membership operators with some examples. Let's see how membership operators work with list, sets, and frozen sets. They will behave the same way. So I'm just taking one example, or example using one data type, and you can then test it with other data types as well and test it out. I would be showcasing or showing the demo with the list. So let's say I have a list 1, and I say 1, 2, 2, 3, 4. And now how it would work is, I will ask if 1 in list 1, which it will check if that particular value exists in that list, or if you are using any other data type like sets or tuples or anything for that particular uh, other data type as well. So for list sets, frozen sets and sets, it will check if that value exists in that particular iterable item or not. So if I run it, you can say it says true. And let's say if I check for any value which is not in the list, let's say 5 in list 1, and it should tell me it's false because 5 does not exist in that list. Same ways, if I check for strings, let's say I give a string text and I say Python programming language, or let's say practice. Now I will try and see if Python is in text, and I will get the answer as true. And remember that it is a case sensitive language, so if you try and search with small p, give you the answer as false, because we don't have Python with the small p. So remember, Python is case sensitive, and if you try, even if you are trying to search for membership using in, and you have changed the any case of any letter, it will give you a false if it's not an exact match. Right now, I tried to search for a word, and you can see it gave me true if that existing. We can also look for the substrings using membership. Let's say I wanted to see if on is there in text or not, and we can see for Python's ending is with on, and it would give me a true there. So it also checks the substrings. Obviously, we also have a space in there. So if I give a simple space, now that also exists in that, so it would also give me that as a true. So let's check that as well. And you can see that also comes as true because we have a space in between. It can also look for the words. Let's say I say to check a small p in text, and there is a small p within programming with practice. So if I hit run, and you will get that answer as a true. So it also looks for the letters in strings. For dictionaries, when you are using the memberships, it will actually look for the keys and not the values. And that's one of the very confusing point for the beginners, that when you're using dictionaries, beginners tend to think that dictionaries will look for the values. You need to remember what is key value pair in dictionaries, which one is key and which one is value. If you have any confusion, please go back, look at the video where I have explained dictionaries in detail. So let's declare a dictionary. Let's just declare that, and I give the square brackets, and I'll say name, and then I'll say Swati, and I just want to simplify, so I'm just going to do this, and then I'm going to give age, and that would be, let's say 30. Let's say location, let's call it Delhi. That should be okay. So that's your dictionary. Now I would look for the key in here. I will say print name in it to, and you will see it as a true because the name key exists. So just to revise, everything on the left is a key, that is name, age, location, and everything on the right, that is Swati, 30, Delhi, are the values stored in it. So when you are using the membership operator in dictionaries, it will look for the keys, okay, not for the values. Let's try the value as well, and if I say print Swati index 2, and you will see it will give me as a false because it won't look for the values but look for the keys for the membership. So please do remember that. Same ways, as I have explained in, the not in will see if that exists, it's not there. So it will give you answer or true if it's not there. So let's say, if I say print Swati and I say not in, pick 2 and it will say true because Swati as a key does not exist. So not in is opposite of in, which will see if this particular value is not a member of that variable. So that's what I checked, and you can see that's what I get true. And not in would work exactly opposite, but the same way as we have checked other everything with the in. So if I say print 5 not in list 1, and it would give me a true because it's not a member of that list, or not, this value is not present in that list. With this, we have come to an end of this video, and we have covered the identity operators and the membership operators, and also have learned how is different from is equal to in Python. In the very next video, I would be covering the last set of operators, that is the logical operators and the bitwise operators. And with that, we would finish the operators in Python. And once we have completed that, from the very next video, we will start the conditional statements, that is if-else statements in Python. If you like my content, please like, share and subscribe, and follow me on Instagram for daily Python tips. I will see you guys in the next video. Until then, happy coding!